Hey there! Ever noticed that little padlock in your browser's address bar? Or maybe you have seen some websites starting with HTTP while others use HTTPS. Today we are diving into HTTP versus HTTPS, what they are, how they are different, and why HTTPS is absolutely crucial for keeping your personal info safe online. Imagine you are sending a postcard through the mail. Anyone handling that mail can read what you wrote, right? That's HTTP. Your data is sent without protection. Now imagine putting that message in a locked box that only recipient can open. That's HTTPS, secure, encrypted, and protected from prying eyes. Well, if you shop online, check your bank account, or really do anything that involves personal information, you need to know whether or not a website is secure. Plus, if you run a website, Google actually prioritizes secure sites in search results. Alright, let's break this down in simple terms. HTTP stands for Hypertext Transfer Protocol. It's the system that allows your web browser to communicate with websites. Think of it as a messenger delivering your requests, like opening a web page, and bringing back responses, like loading the page's content. But here is the catch: HTTP is completely unsecure. Everything you send or receive is unencrypted. It's like shouting your personal information across a crowded room. Hackers, your internet provider, or even someone on the same coffee shop Wi Fi can potentially see what you are doing. This makes HTTP dangerous for logging into accounts, making payments, or entering personal info. Would you write your credit card number on a postcard? Probably not. Okay, but you might be wondering, how do we fix that security nightmare? With HTTPS, it's an extension of the HTTP protocol and uses SSL TLS encryption, which means data is scrambled into unreadable code until it reaches the intended recipient. HTTPS prevents those man in the middle attacks where hackers position themselves between you and the website to steal your information. It also verifies website authenticity, ensuring you are connecting to a legitimate site and not fake one set up to steal your data. HTTPS isn't just nice to have anymore. It's absolutely essential for any modern website, especially if collects any kind of personal or financial information. For website owners and users alike, HTTPS matters for several key reasons. First, it prevents cyber attacks. With HTTPS, those man in the middle attacks, phishing scams, and data breaches become much harder to pull off. Second, it protects sensitive information. Your passwords, credit card details, personal messages, all that stuff gets encrypted so it can't be stolen during transmission. Third, and this matters a lot for website owners, it boosts your SEO rankings. Search engines rank HTTPS websites higher than HTTP sites. Finally, it builds user trust. That little padlock icon makes visitors feel safe on your site, which leads to better engagement and more conversions. Let's dive deeper into how this security actually works. Don't worry, I'll keep it simple. TLS stands for Transport Layer Security. It's the protocol that secures HTTPS by encrypting the communication between a client and a server. It ensures that the data exchanged remains confidential and cannot be tampered with. Let's take a look how TLS 1.2 handshake works step by step. When a user visits an HTTPS website, the browser first establishes a connection with the server by initiating a TCP handshake. You can check out my previous video about TCP versus UDP where I explain how the TCP handshake works in detail. Then the TLS handshake takes place. The browser sends a client hello message to the server specifying supported TLS versions, ciphersuit, encryption algorithms, and a string of random bytes known as the client random. Once the client hello received, the server responds back to the client with a server hello, selecting the TLS version, ciphersuit, encryption method that both the client and server support, and another random string of bytes generated by the server that called server random. The server provides its certificate to the client, which contains a lot of things. One of the key things is the public key of the server. The client uses it to apply asymmetric encryption. Asymmetric encryption involves encrypting data with a public key which can only be decrypted using the corresponding private key. At this point, TLS handshake phase is finished. After receiving the server certificate and public key, the client starts key exchange phase. As an example, we are using RSA for the key exchange, but the actual cipher suit and key exchange algorithm can vary based on what is negotiated between the client and the server. The client generates a pre-master secret to establish a shared session key between the client and server. It encrypts this pre-master secret with the server's public key and sends it back to the server. Only the server which holds the private key can decrypt this pre-master secret. Both the client and server independently generate the same session keys from the pre-master secret. These session keys are symmetric keys, meaning the same key is used for both encryption and decryption. The client and server will use these session keys to encrypt and decrypt the rest of the communication during the session. Both sides send a finished message signaling that handshake is completed and encrypted communication using session keys can now begin. From this point forward, all the data flowing between you and the website is encrypted and secure. The handshake process in TLS 1.2 and 1.3 follows a similar flow but with key improvements. It removes outdated cipher suits, simplifies handshake steps, and speeds up the process by allowing client and server to quickly agree on encryption methods and securely exchange keys. Additionally, TLS 1.3 supports a faster zero RTT mode for session resumption, where the client can reuse shared secret from a previous session, skipping the handshake entirely. So there you have it, HTTP versus HTTPS, explained in simple terms. Whether you are just browsing the web or running your own website, security should always be a priority. HTTPS isn't just about encryption, it's about trust, better search rankings, and protecting yourself and your users from growing online threats. Every website I build now starts with HTTPS as a non negotiable foundation. I used to think SSL certificates were expensive and complicated to set up, but these days most hosting providers offer free certificates through Let's Encrypt. There is really no excuse not to secure your site anymore. Have you started noticing that not secure warning more often when browsing? It definitely makes me think twice before entering any information. I'd love to hear your experiences in the comments below. Thanks for watching and don't forget to secure your connections out there. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more tech breakdowns like this. Stay safe online and I'll see you in the next video.